In this video, I want to go over with you the types of minerals. So before I do that, I'm actually going to back up and talk about this important concept, density and specific gravity. So density is how much um, weight is packed into a certain unit of volume. And so it's how dense, it's how much stuff is crammed into a singular space. So certainly, like if you're holding a handful of cotton balls and then a handful of rocks that are the same size, they have different densities. So specific gravity is important because specific gravity is how dense something is compared to the same amount of water. And so here in this example down here, I just want to explain what's down here. The specific gravity of pyrite, that's fool's gold, is 5.2. That means if you have a cup full of pyrite and a cup full of water, the pyrite is going to be about 5.2 times heavier. And gold, if you had a cup full of water and a cup full of gold, the same amount, the gold is going to be 19.3 times heavier. So it's the density compared to water. Okay, so there's different types of minerals. There's different mineral groups. The first one is the silicates, because this is the biggest one. So oxygen and silicon are the two most abundant elements in the Earth's crust. And there's actually a question in the back of the book that you need to answer about that. So oxygen and silicon are the two most abundant elements in the crust, and they make up the silicates group. And the Silicates Group are cool, and they actually make this cool, like square tetrahedron shape. And there's some like visualizations of that. And then there are some examples here and how they break and fracture, which is really cool. Then there's also the carbonates, and carbonates are oxygen and combining with other things, and often those are metals. And so it makes up different things like limestone and marble. This is a lot less abundant. There's a lot less of this. And then there's the oxides. So the they're just oxygens and metals together as well. So that's a different group, and one important one is uranium, as it says there, that's used in making nuclear power. So there's certain minerals that are actually worth money. There's lots of minerals just laying around outside in dirt and soil and whatever, but minerals actually become valuable if you can make money off of mining them. And so ore is basically a general term, something that contains a mineral that can be used as profit. So hematite, for example, is an ore that has iron. So that's very important to people to have iron. It's been used for thousands of years for lots of different reasons. And then another common one is titanium. Okay, so mining, if we can stay on that for a minute, mining is so rarely do people that are mining actually just come across a giant chunk of exactly what they need. Usually they have to extract it from the other rocks around it, and that's a very expensive process. It really can be dangerous and harmful to the environment and let off different toxins, but we use that stuff. So we find it very useful. So there has to be like a cost benefit balance to mining, but of course, like reusing and recycling is important, and I don't want to undermine that, but mine oh, no pun intended. but um but mines in and of itself, we usually they have to dig very deep in the earth and separate that off from the other rock. And if that becomes too expensive of a process, that means that that mineral basically wasn't worth it. So there's a history of different minerals over time and how it was used. So here is a chart with just the classification of minerals and basically how it's used. This is really cool, I think, if you can just read, the oxides, and here's different things that they're, they can be like a gem, like a ruby or a sapphire, or they can be a source of titanium. You look at, which one didn't we talk about? We did not talk about the halides, which can be fertilizer, salt, weed killer. It's used as a preservative. So important. Then there's native elements like gold, which of course we've used over time, pencil lead, jewelry, all kinds of different things that it can be used for. So gems are obviously highly prized, and they're just considered very hard and scratch resistant, usually very colorful and very shiny. That is definitely a mineral that is highly sought after. So answer these questions here at the end, and let me see if I can give you some help on those. I gave you help on number 2, and number 3, I think you can figure out some environmental effects. Here, number 4, why is the mineral opal often referred to as a mineraloid? If you called someone a humanoid, or if you called something a humanoid, you would probably picture a robot, right? Meaning that it's like a human, but it's not really a human. So a metalloid, or I'm sorry, a mineraloid is something that's not actually a mineral, but has some mineral-like properties, which is why opals get called that. And then if you look at number 5 here, it says which metal is better to use in sporting equipment and medical implants? Titanium, which has a specific gravity of 4.5, or steel, which has a specific gravity of 7.7. Well, if you looked at weight, if you were going to be using a wheelchair with wheels that were titanium or steel, and this is 4.5 and this weighs, basically 7.7, certainly the titanium would be better. But then also, steel has some iron and oxygen in it, which means it could basically rust over time. So that's cool to think about. Take care, and I hope you have a great day.